Hi guys, this is Mrs. Cerami and this is your first screencast from me. I'm going to try my hardest to create videos from me each day unless a Khan Academy is beyond what you need and I'll post that for you. We're going to review 4.8, the quadratic formula. You already learned this in Algebra 1. It was reviewed within geometry as well, and we're going to quickly review it and utilize it today with complex numbers. The question is, again, when do you use this? When solving a quadratic equation, which is again x squared, you always want to try factoring first. If that doesn't work, then you use the quadratic formula. Quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, this is the quadratic formula that you will be writing out and using. And this will give you two solutions usually to where the graph intersects the x-axis. So again, what we're solving for is x, which means where the graph intersects the x-axis, or the parabola in this case. So first we're just going to review how to find a, b, and c within the formula. First step is you need to make sure it equals 0. A is the coefficient of the x squared term, b is the coefficient of the x term, and c is the constant. Make sure that you put the signs with the number because that is actually the sign of the number. Here, it is not set equal to 0, so you need to do that. Subtract 5 from both sides, and you get 3x squared plus x minus 5 equals 0. So now we know that a equals 3, and it is very important to list this. The more details you list, the less chances of you making a mistake is possible. I would pause this right here, and I'm going to work through this, but why don't you try 3 and 4 on your own, pause it. When you unpause it, you'll see the answers. Okay, assuming you unpause it, it's equals 0, so a is the x squared coefficient. There is no x term, so b equals 0, and c is the constant. Here, set all equal to 0, but you do want to bring these two guys over here. You always want your a term to be positive. So we're going to have 5, let's erase that. Oops. So we're going to have 5x squared minus x minus 6 equaling 0. So now we have a equaling 5, b equaling negative 1, and c equaling negative 6. So we didn't solve for anything yet. All we did right now is just list it. Now we're going to solve it. So an example without imaginary numbers. This is an Algebra 1 review right here. It's set equal to 0, a equals 1, b equals negative 4, and c equals negative 8. So what I would do for each problem is write the formula out so you physically can see it. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And you're going to substitute the values in for the variable. Negative b means opposite of b. So whatever b is, you write the opposite. Opposite of negative 4 is positive 4. So 4 plus or minus b squared. So b squared would be 16. Negative 4 times negative 4 minus 4 times a, which is 1, times c, which is negative 8. Use parentheses, otherwise you're going to make a mistake with the operation or signs. All over 2a. 2 times 1 is 2. Okay, now inside the radical, we're going to call that the discriminant in a little bit. You're going to use order of op. We have two operations here, subtraction and multiplication, so you're going to multiply first. So what you're going to do here is, and we'll change colors here so you can see a little bit better. Can I change colors? Yep, pen color. Okay, so bear with me. What we're going to do is we're going to do the multiplication here first. So order of op, you multiply first. Negative 4 times 1 is negative 4 times negative 8 is 32. So it's a positive 32, so plus 32. So again, how did I get this? Negative 4 times 1 is negative 4. Negative 4 times negative 8 is 32. And now we're going to do it all over 2. So inside the radical is now square root of 48 over 2. And we know from even our class when we reviewed, you always have to simplify the radical. So that's the same thing as 4 plus or minus 16 times 3. So 4 root 3 over 2. Now, if you could divide all three of these by the same number, then you can, only if it's all three. And you can divide all three by 2. So this is going to equal 2 plus or minus 2 root 3. So this really gives me two answers. So the answers, and you can keep it as plus or minus, but just so you can see this, the answers are going to be 2 plus 2 root 3 and 2 minus 2 root 3. So you have two real number answers here. And I have no problem if you keep your answer as 2 plus or minus 2 root 3 because we cannot simplify that. So that's algebra 1. Algebra 2, we're going to talk about what's inside the radical, so the discriminant. So the discriminant is b squared minus 4ac. It's that number. So a discriminant is actually going to be, for you, an integer. Okay, it is not going to be under the radical. The discriminant tells us what kind of answer we're going to have. So in the previous slide, the discriminant equal 48. Inside the radical was 48. 48 is greater than 0. So therefore, we're going to have two real roots, which we had. If the discriminant equals 0, if you simplify this number and it equals 0, you're going to have one real root. So what that means is that the vertex will be on the x-axis. And if it's less than 0, then you're going to have a negative number inside the radical, which means two complex roots. And we're going to be focusing on a lot more of those today. So for this, you just want to determine the discriminant and number or type of solution. So this is all we're going to do today. And then tomorrow we'll actually simplify the quadratic formula using negatives. I just want you to understand the discriminant and what that gives us. So to find the discriminant, you're going to use b squared minus 4ac. And again, a equals 4, b equals 4, and c equals 1. So we're going to have 16 minus 4 times 4 times 1. This will give me 16 minus 16, which is 0. So the discriminant is 0, so that means we're going to have one real root. So what I'm asking for you guys to give me here is the discriminant in terms of a number and the type of roots we're going to have. Again, if it equals 0, it's one real root. If it's less than 0, two complex, and greater than 0, it's going to be two real. So again, A is 6, B is 5, and C is 1. And you can feel free to pause anytime, work on the problems, and come back for the solutions. So we're going to have, again, b squared minus 4ac. So we're going to have 25 minus 4 times 6 times 1. So we have 25 minus 24, which is 1. So the discriminant is 1, and we're going to have two real roots. So again, that's an example of equaling 0 up here if the discriminant is greater than 1. And then let's see what this gives us. So when you're rewriting this, you always want A to be positive. So I'm going to bring these guys over to the right. So we're going to have 2v squared minus 4v plus 3 equals 0. So here we have A equaling 2, B equaling negative 4, and C equaling 3. So when simplifying this, we're going to have b squared minus 4ac, and we're going to have 16 minus 4 times 2 times 3, which gives me 16 minus, so this is 8 times 3 is 24, which gives me negative 8. So my discriminant is negative 8, which gives me two complex roots. If you haven't paused it yet, I'd pause it now. I'm going to just not do the work, but just write the answers for 2, 4, and 6 over here. I'll do that in red. And so when you come back, you can just compare your answers again to see if you're right, just like we usually do in class. So you can pause here. Okay, so the discriminant here is negative 71, which means 2 imaginary. The discriminant here is 0, which means 1 real solution. And the discriminant here is 81, which means 2 real solutions. Okay, so you're finding the discriminant and the type and number of solutions for this. Tomorrow, we're going to be solving for x. So once you get into the practice of doing b squared minus 4ac, this will be really easy for you, especially combining with Algebra 1. So this is going to be tomorrow's work. The homework for today is, again, just finding the discriminant and then state the number and type of solutions. I hope your first video was clear. Any questions, you can always message me before 4. Have a great day, guys.